Acute myeloid leukemia AML cells are the immature abnormal white blood cells. They multiply uncontrollably in bone marrow and blood. They do not get mature, crowding RBCs, WCs, platelets, basically leading to blood cancer. Here in this paper, they have targeted completely new site of FLT3 kinase that has never been explored before, and that is CYS807 target amino acid target of FLT3 kinase. Also, they have found new covalent inhibitor for the same site. In this paper, they have used the concept of Michael addition reaction. Yes, they have found the way of interacting one acrylamide site with CYS807 leading to reaction. Remember, not interaction between your inhibitor and your target site, but a reaction between them. And we know that the reactions are they have used especially irreversible reaction. Do continue with the video. Here I have explained all the medicinal chemistry, synthetic chemistry aspects, as well as kinase inhibition understanding aspects of the paper. All the very best. Friends, today's paper is again from Journal of Medicinal Chemistry. So here in this paper, you can see the title of the paper, Discovery of FLC8 as the first covalent FLT3 inhibitor targeting CYS807 for FLT3 mutant acute myeloid leukemia. Okay, so here I can tell you that this paper is a great combination of medicinal chemistry as well as, let me highlight it, and your kinase inhibition understanding. Okay, so in this paper, let's dive into the abstract directly. FLT3 is a validated therapeutic target in acute myeloid leukemia. So in the start of this video, I have told you what is myeloid leukemia, and here FLT3 is a validated therapeutic target has been told. That means to target AML, you can target FLT3. Okay, FLT3 is FMS like kinase 3. Okay, is a protein involved in the cell growth signaling. Okay, so basically it becomes over if it becomes overactive, if this kinase becomes overactive, cancer cells grow uncontrollably, which leads to AML condition. Okay, so here they have targeted previously unexplored site that they have told here. Okay, yet resistance mutation frequently limit current inhibitors. Currently जो inhibitors sorry, I shifted to Hindi automatically. So currently available inhibitors, they are limited by resistance mutations. Okay, time to time there are mutations in this in these cells which led to mutation in FLT3, or you can say mutation in FLT3 leads to the mutation in the target cells, and that led to the inhibition of those kinases. Because if there will be a change in the site of the target, mutation, what is mutation? Change in the site of the target. Okay, if there is change in the site of the target, that in that case drug will not be able to get attached to the target, and so it will not work. Okay, so here we report a, sorry about that, here we report a series of 6 methylisoxazone pyrimidine 3 amines. You can see the structure here that covalently targeted CYS807. This is the This is the highlight of the paper. Okay, guys. So here they have targeted really new site. They have explored this site. So they have kind of introduced new new drug and a new site. Okay, this is the highlight of the paper. Okay, now compound 18 they have mentioned here works on both. Okay, they are saying further that FLT3 compound 18 potentially inhibited FLT3 WT meaning wild type with FLT kinase which is wild and clinically relevant mutant. Okay, and its mutant forms are also inhibited by this compound. Okay, they have displayed over here. Okay, covalent engagement of CS807 confirmed by mass spectroscopy, peptide mapping, and loss of activity upon C807S mutation. They are saying that uh, they have found the covalent reaction has been placed between the target CS807 and this compound. This is a great approach they have found. You must have heard about the Michael addition reaction. So something similar happened here. So CYS807 meaning it is cysteine. Okay, cysteine has SH group, right? SH group is always there. Let me write it down. Okay, I will try to write down. Okay, SH bond is always there. Okay, guys, please uh mm, forgive me this I'm trying to do it with the mouse. Okay, so this sh will kind of follow the Michael addition reaction over this acyl group, and this kind of things are happening over there. So this makes this paper kind of more interesting. Okay, so here they are saying that this kind of engagement happened there, which they confirmed using these all the studies. Okay, especially mass spectroscopy. FLC8 suppressed FLT3 mediated STAS 5 ATK ERK signaling induced apoptosis in AML cells. Now they are saying this is important. Okay, this compound they have reported, this compound has mediated that means downstreamed STAT5 AKT ERK signaling. Okay, these are the pathways, guys. These are the pathways. I will just highlight a bit. Okay, now these are the pathways. This pathway, this is for survival of the cells. Okay, that are getting growing, that are growing and leading to AML. Okay, AKT is for growth. Okay, their growth is controlled by this pathway, and ERK is for proliferation. Proliferation. Okay, proliferation. All the people from bio background must know proliferation, but people from chemistry might get confused. Proliferation meaning the multiplication of the cells. Okay, all all these all of these are pathways that are followed by FLT3 kinase. Okay, and that leads to the growth of the AML. Okay, so they have targeted all these this compound they have discovered, targeted all these downstreamed all these pathways. Okay, downstreaming meaning it has kind of blocked these pathways. Okay, so it will block the survival, growth, and proliferation of the FLT kinase. That means it will suppress FLT3 working, and eventually leads to the apoptosis of AML cells. Apoptosis meaning death of AML cells. Okay, Okay, now they have here they are saying that it is the working of the molecule or drug is in low nanomolar potency. Okay, however, whatever they have reported, if you have some idea about Michael addition and this working of reaction between CYS807, or if you know this protein properly, you can incorporate your idea and make it even better. Okay, so I really like the paper. Okay, if you also did like the paper, go and read the paper, and yes, all the very best for that. Here further in this paper, they have shown first generation FLT3 inhibitors, second generation FLT3 inhibitors, and irreversible covalent FLT3 inhibitors. Now, first and second generation, inhibitors actually kind of, you know, faced problems selective, especially first one were not selective of the kinase. Okay, they were hitting multiple kinases. Okay, so they had side effects. Let me write down some of it. They had what low selectivity, low selectivity. Okay, and they had side effects. Okay, side effects. Okay, okay, and side effects like cardiovascular issues, bleeding. Okay, those kind of. Okay, second one were resistant. They were facing resistance mutation. Okay, so if there is change, there is mutation in the kinase, they were not working properly. Okay, now, irreversible covalent FLT3 inhibitors, what they do, they react, they do not interact. Okay, they do not interact. No, they do not interact. Okay, they react. Okay, this is the specialty of these FLT inhibitors. They react. Okay, so here they have interesting groups which can react with the available amine groups of the protein and leads to the great results. Okay, now, when it comes to the chemistry part of the paper, you can see here the molecule. Okay, here is this is hinge part. Okay, this is your linker part, and this is your uh, warhead. Okay, they have called it warhead. Okay, so hinge part, this interact with ATP. So it is a part containing heterocyclic cores. Okay, here will be heterocyclic cores. These heterocyclic cores can be anything. Okay, like anything in the sense heterocyclic cores. Okay, quinozoline. Okay, quinozoline, pyrimidines. Okay, note down them. Okay, so that you can use in your paper. Okay, here is the linker part. Linker positions the warhead. Okay, this linker helps to position the warhead. Okay, so it decide position of warhead. Okay, now position of warhead, that means length length of this linker matters. Now this is going to interact with your not interact, react with CYS807. Okay, Michael Michael addition happens, that I have explained in the abstract part. Okay, so guys, they attempted this for designing this tail. They attempted different kind of substitution here, but acrylamines, okay, acrylamines showed the uh, showed the path breaking kind of results, and here you can see, and this is the FLC8 molecule they have showed in the abstract also. Okay, so here this part is very important. Plus this CF3 might be creating some kind of we can say changes, or we can say interactions, but they haven't kind of uh, studied them, and they haven't revealed any that kind of study. This is the mass spectroscopy analysis. They have shown how protein with DMSO and how protein with FLC8 showed the increase in the mass. So definitely FLC8 is getting reacted with the protein. That means the reaction is there is no interaction, but there is a reaction and it is irreversible. Okay, yeah. Here they have shown how FLC8 is selective to the kinase. That means they have tested it against different other kinases. Okay, in this study they have shown how it is working in vitro studies, and they have shown the in vivo studies also. Okay, and here they have shown apoptosis process. They kind of not discussed but revealed in abstract also. Here you can find the synthetic part. All the reactions are mentioned here, and all the datas are also mentioned here. All in all, this is a really good paper from medicinal chemistry again, and you can work around these heterocyclic uh, course for designing your molecule to act with protein. Also, you can use the idea of reaction of cysteine kind of part of your protein to react with your available or designed molecule to kind of target the protein properly. So all the very best, and I really like the paper. I hope you also like the paper. Go and read the paper. All the best.